Hi, and welcome to the Advanced FTD Lab. This is going to be a lab introduction. What I'm going to do is talk a little bit about the new features, which is one of the key goals in doing this lab, is to learn those new features. Then I'm also going to talk about the lab itself and talk a little bit, give you some ideas of what you want to do. Before I jump into that, I want to give sort of a short recap of the history of this product. This product is really only about 1.5 years old. We gave the minimal viable product back in March of 2016. That was our 6.0.1 release. Over the releases 6.1 and 6.2, we put a lot of effort into getting feature development because there was a big feature gap between FTD and the ASA that was causing obvious problems with migrating people to this solution. Now, starting with 6.2.1, 6.2.2, which you're using today, which was released in September 5th, and 6.2.3, which will be released hopefully fairly early next calendar year, we're really taking a different tack. We're focusing on hardening the product. We're actually going through most of the code, rewriting it. We have more of a sort of SLA on what our acceptable number of bugs is. We're really tightening that down. And preliminary feedback from 6.2.2, and I'll admit it's a little early, is very encouraging in terms of those quality developments. Now, I don't want to say that we're not doing feature development as well. We are, but we're temporarily slowing the feature velocity through 6.2.3 to sort of enhance the quality. So let's talk about the two key features that we did introduce. Now, technically, we introduced remote access VPN in 6.2.1, but really 6.2.1 should be viewed as an interim release. It was the reason we had a 6.2.1 release is we had these 2100s. We wanted to get them out the door. We wanted to be able to sell them. It's easier to qualify a release if you only qualify for one platform. So we sort of said, okay, we can get this out sooner if we just qualify 6.2.1, leave out a few things, and just qualify it for the 2100 series, and we can start selling it. But no one should really continue to use 6.2.1 now that 6.2.2 is available. And 6.2.2 is available on all platforms, and remote access VPN is provided on all FTD platforms. Now, I don't think I have to belabor the use case for remote access. This is key. This is one reason why we considered it part of the MVP for the 2100 series. And I just want to emphasize the benefit to having it integrated in the firewall. And that is that as soon as you decrypt the traffic, you can apply the advanced security capabilities, AVC, anti-malware, IPS, and so forth, and all the identity to the traffic. And even if the traffic is hairpinned back out to the internet. So as you'll see in the lab, we do offer split tunneling. As a matter of fact, that's what we do in our lab. But you could actually avoid split tunneling and do what we call backhauling and send all the traffic to the head end and get all that great advanced inspection, even when the people using the VPN are surfing the net. Now, there is a feature disparity between the FTD today and the ASA. And I will justify this by saying that, as you know, AnyConnect is a very mature, feature-rich product. So we did not port all the features over. We made a decision based upon what we felt was a reasonable set of capabilities, and that includes the basic ASA. Now notice I say SSL and IPsec. I just want to remind you that AnyConnect can do IPsec. Most people think of it as SSL. Most people use it as SSL. But we have customers that require IPsec, and that's, of course, available. Time ranges in the connection profiles. The AnyConnect client is what we're supporting. The proxy assignment, the simple configuration, simplified, so we have a wizard, in other words, and the basic session monitoring and control. Some of the key things that are still missing are some of the advanced AAA, including the Radius COA. That's kind of the big one that we're working on getting it in. Another thing people ask about is local authentication. No, you cannot create local users on the FMC and authenticate against them. That's not there yet. Host scan endpoint assessment. We are actually going to get that in, but it was less of a priority because we were sort of pushing the ICE solution, the Identity Services Engine, and that's what you'll notice we're using in the lab today to use Radius attributes to assign group policies and things like that. So theoretically, if you have ICE, you're going to be doing your endpoint access control using ICE, and you wouldn't necessarily need these features. Dynamic access policies, some of the more advanced capabilities are exposed through dynamic access policies and through even a Lua interface for Lua scripting. That is not yet available. And another big one is the clientless remote access VPN. This is not a priority. Frankly, the need for Java in the clientless solution really means that it's not something we want to make an investment in. We're looking at a fundamentally better way to do VDI, basically, than with the clientless remote access VPN. Now, there's some intrinsic complexity in configuring an RAVPN head-end. So I don't want to say this is easy to do. What I will say is if you've done this on an ASA, this is easy to do. I had no trouble after years of doing this stuff with an ASA to adapt to the FMC. And by the way, we also have this on the FDM, and that was easy too. If you understand the basic components of the remote access VPN configuration, you'll have no trouble understanding what's going on. I think you'll feel that way when you do Lab 3. I just wanted to quickly go through this. You have to configure the interfaces to allow AnyConnect, to enable AnyConnect typically on your outside interface. You could do it on any interfaces you want. We want to be able to do image management because we want to be able to do a web deploy, right? So that the client doesn't have to, the endpoint doesn't have to install anything separately. They'll connect to the head end and they'll get that web installation. So you have to be able to manage images. You have to be able to manage client profiles. Here we have a very slight feature gap with the ASDM. The ASDM, as you know, probably I hope, if you've worked with it, is that there's an AnyConnect client editor built in. That's pretty convenient. Here in the FDM, FMC, we do not have that editor built in. We actually have a link, so we make it pretty easy. Click, download, install, edit. But it's not built into the UI. That's a little difference. And by the way, there's a client editor in the pods. We've went ahead and installed it for you, although it's not part of the exercise. You're not going to be editing these profiles. We just give you a profile to use, real simple one. Connection profiles. This is how you decide how to authenticate, right? That's kind of key. And then the group policies do a lot of stuff. You should be familiar with that. Now, as you may have know or have guessed, when we add features to FTD, we typically add objects. Features require new objects, and so you might expect to find these objects that I talked about on the last slide in the object. If you go here, you'll see some of them, but not all of them. We see the group policy. That's great. We can configure group policies. We see file, the word file. If you clicked on that, you'd actually find out that does two things. There'd be two things you can do from the drop-down. You can do packages, and you can do the client profile, the XML files. And as a matter of fact, you'll do that in the lab. Okay, that's three of the objects. And well, IP pools, of course, are important. There's some PKI stuff that you can't really see here. But there's definitely something missing. The connection profiles, doesn't look like you can create a connection profile, and there is no place, well, I wouldn't look here for it, but if I went looking in the device page and everything, there's no place where you do the interface configuration to allow AnyConnect on an interface. So that's what's a little bit odd, especially if you're one of those people that's always done this stuff from scratch. I hate wizards. I think that they obfuscate configuration, and in the long run, you understand things worse. So the way I was taught and the way I had always done AnyConnect on the ASA was to do everything sort of from scratch. On the FMC or FDM, you cannot. You cannot create a connection profile from scratch. You have to run the wizard. By the way, it's very easy. It shouldn't be a problem for anyone. And everything is very intuitive, so you'll run the wizard in Lab 3. Once you run the wizard, it creates an object. I think of it as sort of a container object, remote access object. I gave it the clever name test policy. It's not really even a policy. But anyway, if you edit it, that object, you will see connection profiles. Now you can add, delete, modify connection profiles. But you have to have run the wizard to have the object to be able to do that. Also, you notice access interfaces there. That's where you have to go and enable AnyConnect on the interface in order for AnyConnect to connect to that interface. So that's my quick introduction to Remote Access VPN and how we're deploying it, how it's a little different from the ASA. I want to now talk about the other really big feature in the 6.2.2 release, and that is Cisco Threat Intelligence Director. Now, I think what we're undergoing now is a natural evolution as we move from the old days where you relied on your firewall vendor to provide a security solution to the newer idea that that's not going to be adequate, that you're going to be consuming threat intelligence from a variety of sources, threat intelligence information. And in particular, there are a number of third parties that do nothing, well, they do other things, that provide as a separate service simply providing feeds of new threats as they emerge. So, and I think that's a trend. As a matter of fact, some of these numbers, I looked at this one report, you get various slightly different answers depending upon who you ask, but they all seem to agree that a lot of people are already doing this. This estimated 60%, and they said another 25% are planning to do it. So that means we're going to be up to 85%. Okay, so that's the situation today. We have third parties that are selling descriptions of threats. The challenges include standardization. Good news is we're really settling on some standards. So that's very encouraging. The other tricky part, though, is operationalizing this information. It's all well and good that you're getting a bunch of descriptions of threats, but how do you tell your firewall what to do to look for those threats? And that's what this new feature is all about. It's called the Cisco Threat Intelligence Director. It actually supports a number of different formats. We're going to use a couple different ones in class. We're going to use sticks, which is becoming a de facto standard. That's why I want to talk about it a little more. And then for our URL list and our That's just a list of line-separated URLs to look for as malicious. So, but I want to talk more about sticks because that's what's interesting. That's the standard that people are settling on as examples: the Department of Homeland Security, Financial Services Information Sharing and Analysis Center, and many other. Settling on the standard for describing the threats, and that's called sticks. Here are some examples of some vendors that offer these that we do testing with, and you'll recognize, some of our partners, some of our competitors right there. But really, don't think of this list as exclusive. Any feed, any sticks file that's consistent with the standards will be accepted by our product. So what's the point here? Well, the point is that a threat can be complex. And I mean complex in the literal sense. It can be a combination of different things that you're going to want to look for in your traffic. It could be a combination of an IP address and a hash of a certain file. Matter of fact, that's the example we do in class. The FMC uses the component of the FMC, the Cisco Threat Intelligence Director, takes that file, that sticks file, and it parses it, and it figures out, okay, you're looking for an IP address, you're also looking for this hash. That's what I'm going to tell the firewalls to look for. So it extracts from what we call the indicator the observables, things that firewalls can observe. Okay? Now then the firewalls report back to the FMC if they've observed that hash, if they've observed that IP or whatever. The FMC then applies the logic built into the sticks file, the Boolean logic, to determine whether the criteria of the indicator have been satisfied. And if they have been satisfied, it generates an incident. That's it. Now, if you want to learn more about sticks, I don't want to discourage you, but I will. It's actually quite complicated. So if you say, I want as my goal to be able to write sticks files from scratch and understand everything in there. Yeah, they're XML files. You can human read them. I don't consider them so easy to read, but I consider them human hackable. In other words, give me a sticks file with an IP address in it. I'll go in there and I'll change that IP address to another IP address. That you can do. That much is easy. But I just want to warn you that there's a fair amount of complexity in the standard. Fortunately, for our purposes, we really only have to focus on these three things that I mentioned before. So to repeat, indicators, that's what the sticks file contains. It contains an indicator. The indicator is broken up into observables. That's what the firewall can observe. The observables are reported back to the FMC, and the FMC decides whether or not it should generate an incident, which means the indicator's criteria have been identified. Now, if you want to start with this, you can use, you can go to Sticks Project if you want to go gung-ho and really understand stuff. Or you could just go to the COSIV generator. This is what I did for this class, the sticks file that I built for this class. I just went to the generator, said, I want a combination of IP address and hash. And it used the wrong hashing algorithm, and so I had to change that, and then I had to change the hash, of course, and then I had to change the IP address, and then I had the file for class. I will warn you, this is a bit buggy, but it's free, so don't complain. So that's a way you can start building sticks files for your own testing. Now, what about how to get sticks files, how to share sticks files? There's a standard for that called TAXII, sort of a play on words, right? And TAXII is very much become the standard for sharing this intelligence. So typically, when you're going to get sticks files from a third party, you subscribe to a TAXII feed from that party that will then feed you those indicators, those sticks files, as the threats emerge. It's free, open source, and that's why it's really gained popularity. Like I said, it's sort of it's become the de facto standard for sharing intelligence. And as STIX has become the de facto standard for describing the threat itself. Now, there's a great free website. At least I thought it was great until today. Today it's down. Hopefully it won't be for the people listening to this. But just in case it's down, you just skip those exercises. Go ahead and try them to see what it looks like to set it up. But if the website is still down, you just won't get the feeds. So you connect there, and you put in what's called the discover. You connect to the website if you want to read the instructions. The instructions will tell you, and this is how it generally works, that you need to connect to what's called a discovery URL, and this is over HTTP. And the discovery URL will then tell you what feeds are available, and then you select the feeds, and you'll start seeing the indicators populate in the CTID. Okay, let's move on to the lab itself. Here's the topology. It looks a little complicated, but I want to really make it clear to you that the details of the topology aren't going to hamper your progress. Most of the devices you're going to be working with ICE, with this FMC, the migrator, most of that stuff is inside the firewall, and then there's an outside, and that's all we have. We have an inside and an outside. And so the FTD, which is our next generation firewall, Power Threat Defense, whatever you want to call it, that's our, of course, straddles the inside in red and the outside in blue. We have a workstation outside that we use. The reason we use that workstation is for VPN, right? I mean, we could have done it from the inside, but it's much more realistic to have someone connecting from the outside. So that's the key reason for that. We have a CSR router. Where does that route traffic to? Well, not really anywhere. Just to local, just to loop back addresses on the router. But this is to do the lab on, there are actually two labs that involve dynamic routing protocols. There's a lab where you configure BGP in the UI, and there's a Flex Config lab where you configure EIGRP. And the CSR is running those protocols, and it's ready for you to form adjacencies with it. So that's why we've got the CSR. Notice we have an outside Linux and an inside Linux. And I'll have to admit, this is one of my prejudices. Whenever I set up a lab, the first thing I do is I set up an inside and an outside Linux box. I don't like browsers. I don't like doing our fundamental tests with Windows, because your browser is actually a very complex program, right? It's doing caching and who knows what. But when I run wget or curl from this guy to this guy, I know exactly what to expect, and I know exactly if something's wrong. So you'll notice that sort of prejudice built into our testing. We do a lot of testing. You could use the workstation if you prefer, but the way the lab is designed, we do a lot of testing from the inside to the outside. FTP for some of our IPS, anti-malware. Like I said, that's sort of been the focus of the lab. We do have a couple other devices maybe you should know about. The branch office, and that's another Linux box, connected to the outside world through the ASAV. I put in an ASAV primarily to give you some variety, but it is pre-configured. So unless you want to dig into it, you shouldn't have to log into that and actually look at it. That is for our site-to-site VPN lab. And so we connect from the FTD to the ASA with site-to-site VPN. And you show that you get connectivity to that branch office server. The isolated, it's kind of a funny name. I couldn't think of a better name. It's isolated at the beginning of the class. It is on the same subnet as the inside devices, but a different VLAN. This is for the very last exercise, the IRB exercise, where you set up a layer 2 interfaces. Now, for those of you not familiar with the new IRB feature on the ASA, we're still in routed mode. but you're allowed to mix now. So our outside interface is still routed, but we get rid of our inside interface and replace it with a bridge group with 2 inside interfaces. And then the traffic between these devices and this separate guy over here, this one Linux server that's on the other VLAN, will go through the FTD and therefore be subject to inspection. So if you're interested in IRB, we have that lab, and therefore we have that extra server. I want to go through the lab outline. The lab guide says that if you did every exercise, it would take you 6 hours. I think that's optimistic. I think it would be more like 8 hours. I wanted to put a lot of stuff in here for your initial experience with this lab, and also if you return. So what I sort of broke it into was the first 7, these are core. What do I mean by core? I mean they're required as prerequisites for all the labs, lab 1 and 2, or they're new features in 622. And the primary goal, the core goal, if you will, of the SEVT is to learn the new features. And then I added a lot of auxiliary lab for a couple reasons. One is you might find yourself either today or the next time you use the lab wanting to do some other stuff. And by the way, it's not limited to that. You send me email. I can give you ideas of how to do, open app ID labs. A lot of identity, captive portal. All that stuff is available in the lab. It's just that we haven't had time to publish all those exercises. So let me know if there's something you want that you don't see here. And we can add it probably without modifying the pod at all. So anyway, so this is just some interesting labs that I sort of chose. And sorry if I left out your favorite subject. And so what are the dependencies? Well, everything depends on scenario 1 and then scenario 2. And if you've done scenario 1, I hope that most of you have done this already. That uses a REST API. It's not the sort of REST API script that we would publish to a customer. It's more one that we cobbled together for this course, but to give you a good feel for what you could do. And if you look at the script, which is in Appendix B of the lab guide, you could easily go way beyond it if you want to. Since I had one of my colleagues writing the script for me, I didn't want to tax him. So at one point I said, hey, that's enough. This is good enough for our lab. They'll get a good idea of how it's used. In particular, I want to say that step where it tells you wait for discovery, we would have probably, for a customer, we would have built some kind of loop in there where you query every few seconds and see whether discovery is completed. You can do that through the REST API and then automatically continue. Obviously, we would have had more inputs and errors and stuff, error warnings. Okay, so anyway, so scenario 1 and 2 should get you set up. Then you can pretty much do any of the labs. If 3 through 6 is a very detailed treatment of remote access VPN, it may be overkill. So, but if you're doing several of those labs, you have to do them in order. You have to do 3, then 4, then 5, then 6. At any point, you can stop. As a matter of fact, you don't have to do any of them. I know some people at the last SEVT, when we were showing 621, already did these labs. They're the same labs. They haven't really been modified since that 621. So anyway, this last point may not apply to too much. If you're interested in pre-filter policies, in order to get the pre-filter policy demo working, we needed a GRE tunnel. In order to have a GRE tunnel, we leveraged a static NAT configuration that was set up in scenario 10. So a minor point, but if you're really interested in pre-filter policy, scenario 13, you have to do at least the static NAT part of scenario 10. Okay, so that was maybe a little vague. Let me, and I'm a little weary of doing this because I don't want to dictate to you what your choice should be for what to do. But I decided I'd give you an example. So this is what I think is a very reasonable example. You do the first 2. That's no choice. That's why it's bold, right? Then I think 2 is a good number of the 4 remote access VPN labs. The first one is your basic setup. The second one shows you how ICE attributes can affect DACLs, the downloadable ACLs, the group policy, and IP pool assignments. So it will go a little bit beyond just the very minimal configuration to one that actually you're doing something interesting with ICE. We don't have you configure ICE because we didn't want to turn this into an ICE class. I do have in one of the appendices some information about what we had to do to ICE to get it to work with the lab. And you absolutely can log into ICE and play with it if you want to go there. But you shouldn't have to log into ICE. It's actually good to do it to maybe see the Radius Live log. I don't know. That's up to you. But anyway, so I think 2 is plenty for remote access VPN. Then please do the Cisco Threat Intelligence Director. And you may, actually that would be maybe most of your time, but if you have some energy left, maybe pick a few more. Here are a few that I find particularly interesting. FlexConfig is probably useful to know if you've never seen it. This is where we write actual configuration to the ASA, to the Lina component. So if you've never seen FlexConfig, it's probably worth doing a little of that. Netting and routing, maybe. I just like those more firewall things versus the security stuff. But anyway, so that's sort of my preference for netting and routing. Site-to-site VPN is another one that you can do. The other that I don't mention here that that may be relevant to you is there's a migration lab where we take 2 ASA configurations and migrate them. So that's another thing you might do. But that would be my advice if I had to give it. Do these 5 and then choose among the rest with the time remaining. Now there are some additional resources. We all know that our Firepower Management Center configuration guide, it's very verbose, thousands of pages. It's great if you already know the product, and this is, I assume, applies to most of you, because it's very complete when you go to look for a feature. What exactly does this attribute on this page of the UI do? So that's, of course, a resource. There are release notes for 6.2.2 that you should look at. The one that you might not be aware of is the REST API Quick Start Guide. Although, frankly, I don't spend a lot of time in that. I do that for the high level, but when I want to really drill down to see how the REST API works, I use the REST API Explorer. Now, I don't have an exercise on that, but I do have the link. So in Firefox, in your pod, click REST API Explorer, log in. This allows you to create policies or modify them. I'll give you an example of what of a use of that. Let's say you need to create 100 objects with network objects with a certain pattern to the networks, a certain pattern to the name. But you don't want to do 100 things in the UI. What I'll do is I'll go to the UI, rather than trying to get it all from the documentation. I'll go to the UI, I'll create one object that looks like what I want, or one access policy role that looks like the one that I need 100 of. So I'll create that one thing. Then I'll go to the API Explorer, and if you get stuck trying to use it, I'll show you. You can go to the API Explorer, you get the JSON chunk from that object, you take that, you put it into some kind of a Python script or Perl script, put it in a loop with a variable, and then voila, you have a way to create those 100 objects that you need. So so not only the REST API Quick Start Guide, but the API Explorer itself, great references for that stuff. And also I want to emphasize that we are trying to use more and more YouTube as a mechanism for communicating information about our next generation firewall. I could get into the details of the channels and stuff like that, but I just say, just go to YouTube and search for Cisco NGFW. There's already a lot of great material up there by some of our really outstanding presenters, and we intend to have much more information up on YouTube to address specific features, including the ones that you're seeing in the lab today. And with that, I'll return the lab to you, and thanks for listening to my presentation.